myself. I'm Linda from the AG Tugas of Electromedic Engineering at the Health Polytechnic of the Ministry of Health in Surabaya. This time, I will try to discuss about the accuracy of the infrared photodiode sensor analysis on the flow rate parameter of the Infusion device analyzer with 2 channels. The steps of this research are designing and processing, prepare material equipment, convening and observing, assembly planning, and process.
Designing and researching. The topic I will discuss is about research on how the level of accuracy of the infrared photodiode sensor on the flow rate Infusion device analyzer parameter with 2 channels. The first thing to do is to make a 2-channel Infusion device analyzer device design, where the device is used to calibrate the infuse pump or searing pump. After the device can be used, photodiode sensor study is consumed. The mechanical diagram of the two systems is follow. Number 1, display LCD character. Number 2, reset. Number 3, up or down. Number 4, start or stop. Number 5, enter. Number 6, flow rate. Number 7, occlusion. Number 8, Arduino. Number 9, connection 1. Number 10, connection 2. Number 11, power. Number 12, power lead connection. 13, dry connection 1, and 14, dry connection 2.
Preparation when are completing material equipment in the form of component needs for the manufacture of a 2-channel Infusion device analyzer. The tool and material used are solder, pin section, avometer, tool set, cutter, and the material with Arduino, infrared photodiode sensor, comparator circuit, LCD character, power supply, lead, E2C, 3-way stop fork, pass button, toolbox, chamber, inlet connector, drain connector, drain hose, and solenoid. Make observation about how the process to find out the value of the flow rate in the Infusion device analyzer to channel using a photodiode sensor.
Planning assembling. System block diagram. When the power button is on, the power supply gets a voltage from the PLN and will supply the voltage to the entry circuit. Before making a measurement, first select the channel 1 or 2 that will be used and adjust the flow rate on the infuse pump or searing pump to be measured. The press start. Water in the infuse or searing will flow to the chamber. The water that flows in the chamber will be detected by photodiodic sensor and infrared. The output of the photodiode and infrared will enter the comparator circuit and will compare the input voltage with the reverse voltage. Then the ADC will change the analog data and processed by a microcontroller on Arduino. Then the LCD will display the results of the time counter flow rate and volume according to the applicable formula. Process or flowchart. First, when the device is turned on, the LCD will initialize. Then, tune the flow rate setting on the infuse pump or searing pump and select the flow rate parameter on this tool. Press start on boot device. The solenoid inlet will automatically open and water will flow from the line to the chamber, which has an infrared photodiode sensor. The sensor will read when there is running water and start counter. After the first measurement time counter is reached, the results will be processed by a microcontroller on Arduino and will be displayed on the display in the form of flow rate and volume. Furthermore, the tool will do the second and the third measurement with the same process and setting but with different sensor. When the final measurement results appear, the inlet in solenoid is closed and the drainage solenoid is automatically open for water discharge.
The factor that can affect each measurement result at one time: the infuse pump and searing pump calibration process, and the measurement result at each calibration process. To find out the value of the resulting flow rate, it can use a dynamic fluid formula, namely discharge is volume divided time or second. Measurement can be done 3 times in a row. Then can be taken the next average value can be seen the standard deviation value, so the error value can also be known.